Manufacturing level 3, task 2, applied. We will start by selecting our stock material to the closest dimension. The biggest diameter on a drawing is 24 millimeter. The closest I have is 30 millimeter. So it means on an OD I'll have to remove 6 millimeter. Where do we start? We start off by doing a facing operation. Why facing? Facing is done for two reasons. One is to get the front of your workpiece straight, and the other one is to bring your workpiece to specific lengths. The overall length of the workpiece is going to be 70 millimeter according to the drawing. So we have cut this to plus minus 90 to give enough meat for the chuck to clamp, but we'll have to support it with a tailstock with a revolving center. So let's start off to face. Clamp workpiece deep into your chuck to ensure it will not get dislodged during the operation. Next step, extremely important, select your correct tool and ensure that your tool is set to center height. This is where many people fail, and neglecting to set your cutting tool to center height can lead to all sort of problems. If your cutting tool is set too high, your cutting tool is going to rub on your workpiece, it's not going to cut. If you set it too low, it's going to dig into the work, and the chances are pretty good that you'll break your cutting tool. So let's show you how to set your tool center height. Securely in your tool post, clamp your cutting tool securely in your tool post, swing around and line up with your tailstock center. Currently you can see the cutting tool is just below center height, but let's just move it out completely so we can see what we mean. There we can see that the cutting tool is quite a bit below, and if I turn it the other way, we'll see that the cutting tool is too high. So it has to be exactly in line with your center. Loosen, slack off to lower, and check. Slightly too low. There. Your cutting tool is center height. Ensure that you tighten and double check. Okay. To face, move your cutting tool to your workpiece and swing it at a slight angle. Swing your cutting tool to a slight angle for the facing operation. Move your cutting tool towards your workpiece and start your machine. Ensure that your chuck is rotating in an anti-clockwise direction because you're cutting into the work. Also ensure that you select your correct rotational frequency for your chuck. For mild steel, using a high-speed steel tool, I've set the machine at 460, and I think that will be sufficient. I'm going to use automatic feed, so ensure that you check your direction of feed before you engage. So I'm using the cross feed, so it is going in the right direction. Bring my cutting tool so it just touch the work, and I'm going to take a light cut. Once again, why do we do facing? One is to get the front of the workpiece perfectly straight, and we're also going to use that as a reference to take all our dimensions from. The facing operation is done, and a quick check to ensure that your tool was set to center height is feel across the face. If there's anything protruding in the center, then you know that your cutting tool was not set to center height. Okay, can stop. Because we're going to support the workpiece with the tailstock with a revolving center, we need to provide a center hole in the workpiece. To fit the center drill, remove your revolving center by just turning your tailstock handle back, and it will just push out your center. Fit your drill and take it forward to your workpiece. Lock your tailstock in position. Now, how deep do we go? A lot of people are confused when it comes to fitting or drilling a center hole. Very simple. If you look at your center drill, you'll see that you'll only go halfway up the slope. That's how deep you will go. Obviously, you get different size center drills depending on your work. This is a relatively small workpiece, so the center drill will be ideal. So that's how deep we're going to drill. You'll see that I'll go forward, slightly back, forward, slightly back, forward, slightly back. And that is just to remove the cuttings. And there, my center hole is drilled. You can see how deep it's halfway up the slope. Right, we are ready to turn down our first diameter, which is, according to the drawing, 24 millimeter. And we're going to turn it to the overall length of 70 millimeter of the workpiece. The workpiece have to protrude more than 70. So this has been cut to plus minus 90 millimeter. That leave me enough meat to cut up to 70. So it's protruding now roughly 70, 75 millimeter, which is sufficient. Lightly clamp. And then bring your tailstock, lock, start, and clamp your workpiece properly. Remember to remove your chuck key, avoid accidents. You'll see in the meantime, I've changed the cutting tool to a tungsten carbide bit. I have ensured that it's center height. And now I'm going to cut for a length of 70 millimeter. To do this, I'm going to use my longitudinal feet on the apron of my lathe, and I have to get the reading to 0. So I've adjusted my longitudinal feet to 0. But the cutting tool is still away from the workpiece, so I'm going to move it forward. Slowly, it's going to just touch the work. So I got it on 0 there, and it's touching the front of my work. So every time I'm going to ensure that I move back to 0 position. Now, how do I move 70 millimeter? We look at our longitudinal feet, and we'll see that each division is 0.15 of a millimeter. So, our trusty calculator, from our 0 position, we're going to move our cutting tool 70 millimeter. And to do that, we take 70 divided by 0.15. It's 466 lines. Now it's going to take a long time, go 1, 1, 1. Each revolution here is 95. So I minus 95, minus 95, minus 95, minus 95. So it's going to be 4 revolutions and 87 lines. So let's do that. 1, 2, 3, 4, and 87 lines. 80, 85, 86, 87 line. You can see I'm still clearing the chuck. So I'm just going to draw a light cut there. So that indicates now from there to that line is exactly 70 millimeter. This guideline there will help me so that I don't have to concentrate so heavy. Right, I'm going to change the direction of my feet. Check my feet that it's correct. And I'm going to take a rough cut so that I can take my measurement and bring down the diameter to 70. We're taking a rough cut, and with this diameter, we're going to bring to a diameter of 24 millimeter. As you reach close to the line, disengage and go to your final on your longitudinal feet. Take a rough measurement with your vernier. This diameter must be brought down to 24, but currently it's still sitting at 28.8. So I'm going to take a 3 millimeter cut. Currently the diameter is plus minus 24.5, so we want to machine it down to exactly 24. So for that we're going to use our micrometer. Micrometer is a very sensitive instrument and students tend to damage quite easy. When you open, always open on your thumble. Don't use the ratchet. We're using a 0 to 25 because the diameter is going to be 24 millimeter. When closing, use your ratchet. Just till the ratchet starts slipping, moving it slightly around to ensure you got the center of the workpiece. And the dimension here is 24.53. Okay. We have to remove 0.53 of a millimeter. Each division on our cross slide is 0.05. So it is 0.53 divided by 0.05, and that gives me 10.6 lines. So make it 11. This is the final cut, and with this cut, the diameter should be 24. The diameter should be 24, let's check. It's 24.03 inside tolerance. So we got our first diameter done. Important, do not remove your workpiece out of the chuck. It's a 3-jaw chuck, and the moment you replace it, you'll never be able to get it to run centric again. So leave it there, complete the whole workpiece before you remove. Our next diameter is 17 millimeter, and that's for a length of 15 millimeter, now for a length of 65. Remember, we have not removed Our longitudinal feed, when I touch the workpiece, will still be at 0 because I have not moved anything. So it's still at the front, and I'm going to move from that position. I'm going to move 65 millimeter. The calculation, 65 divided by 0.15, that's 433 lines, 4 revolutions and 53 lines. A very light cut so I can see where the line is. That line is at exactly 65, which relate to 4 full revolutions and 53 lines. This diameter must be taken down to 17 millimeter. Currently it sits at 24, so it means I have to remove 24 minus 17. 7 is at 24, we have to take it down to 17, so 7 millimeter that I have to remove. I'll do 2 cuts to get it down to size. 1 cut, measure, and then we'll take the final cut. The diameter is going to be taken down now to 17. Remember, on the ratchet, not on the thumble. Diameter is 19.02. Diameter must be 17, currently is 19.02, divided by 0.05. So it's 2.02 divided by 0.05, 40.4 lines. So it's 40 lines. 10, 20, 30. And remember, you must just go forward. You can't go backwards. You can't take up the play. 40 and done. We've taken the diameter down to 17 millimeter for a length of 65. .03 inside the tolerance. Next diameter is 12 millimeter for a length of 15. Same, 15 divided by 0.15 equal to 100 lines, which is 1 revolution and 5 lines. Measure, and then we'll take a final cut down to 12 millimeter. Measurement 12.04. Fine. All these corners are extremely sharp. So we're going to put small chamfers on them, and this front one, where you're going to put, according to the drawing, we're going to put a 2 millimeter chamfer. For that, we need a chamfering tool. So I'm going to replace my knife tool with a chamfering tool, which is a 45-degree tool, and I have to ensure that my tool is center height. happy it's center height. Put it straight and replace your tailstock. Put small chamfers just to break the sharp edges. And then a 2mm chamfer on the front here, using your compound slide. Next step is to drill a hole for tapping. The size of the tap is an M8. So for an M8, we're going to use an M8 tap. M8 is M8 by 1.25 pitch. So 1.8 minus 1.25. Supposed to give you a 6.75. The closest drill I have is a 6.5mm drill, so that's what I'm going to use. I'm going to drill a hole 15mm deep according to the drawing, and I'm going to drill it 6.5. It's supposed to be 6.75, but that's the closest I have. For the hole, I'm going to use a ruler on the tailstock spindle. Currently is sitting at 20, so 20 plus 15 is 35mm. Remember, drilling forward, backward. Just a reminder to go forward and backwards to remove your cuttings. Vernier to check your depth, and it's at 15.3mm, slightly longer. It's fine. Now we're going to tap. Okay. 3, your taper tap, your intermediate tap, your bottoming tap, sometimes also referred to as a gun tap. So we're going to start off using our taper tap, and I'm going to use my tailstock to assist me to get my tap exactly straight. With the aid of your tailstock, you can get your... Okay, wacht, kom ons doen hom weer. Okay. Ensure that your machine is properly switched off into a low gear so that it's difficult to rotate your chuck, and now you can start tapping. As you go forward, you use your tailstock just to assist you. Once you're happy that you've got it straight, now you can start tapping. Remember, half turn forward, quarter turn back. Half turn forward, quarter turn back. That's to break your chips so it doesn't seize up. At some point you're going to feel that it hits the bottom. There. Don't force it, you're going to break the tip. Repeat with your intermediate tap, that's number 2, and then the bottoming tap. tapping, clean your taps and return to its box. Okay. All the machining on this side is done. All that's left is to bring the workpiece down to a length of 70 millimeter, and for that we have to remove. We can, okay, we're going to shorten this workpiece by using a parting tool. This is quite a delicate operation. These are not the best quality machines. There's a lot of play on the slides, so it might be better just to keep on facing it till I get it to the right length. But let's see parting, we'll try. We are parting here. I've reduced the speed considerably, and I'm using some cutting oil, or I can use soluble oil as well. The whole idea about parting is to go to the middle of the work and it will remove that whole piece. Okay. We've parted it off. There's still a bit left there, and that we'll do with a knife tool to bring the workpiece to exactly 70 millimeter. Replace. Check that your tool is center height. Swing to a slight angle and take a light cut. We can measure our workpiece, the length, and it's 70.2 millimeter, so 1.2 millimeter must be removed. For that I'm going to use the compound slide. Take my compound slide, and I'm going to turn it forward, not backwards, forward to 0. That is to take up all the play. Bring your cutting tool till it just touches the work. And 1.2 divided by 0.025, it's 48 lines. So here I'm going to go 10, 20, 30, and I'll take a final cut of 18 lines. with this cut, the length will be 70. We're also going to put a chamfer at the back, just so it doesn't cut your fingers. Just a very small chamfer. Okay. About a small chamfer, just to break the sharp edge. Measure the final diameter, final length, 70 millimeter. Workpiece is complete. Now it's for cleaning the machine and pack away all the tools, especially the measuring tools. Work complete, Chala time.